So, area between two curves with respect to x. We know from previous lessons on how to find the area by doing the accumulation of the cells and so forth and so on. So if you draw a nice little, let's draw a graph here. Let's draw some little graph here. Okay, I'm going to call this my function A. Okay. Well, actually, erase that A. So that's going to be my graph F. And then I'm going to come in with another graph. So we know currently, if I ask you to find the area underneath f of x, we know that, we could do the integration. We could do adding up all the area here in like squares and all that junk if they had nice geometric shapes that we could do. We know that's the area underneath f. If we bring in, as I erase all those little marks there, if I bring in a second function, and let's say we're going to call it g of x, and g of x comes down and goes up, and when they ask me to find the area between g and f, then that's mainly focusing in on this part right there, is what I'm asking, what's the area between the two curves? Where is the overlap between the two? Because we know technically the area under G is the stuff like that's below the green line to the x-axis. And so if they wanted us to find the area between the two, it's like, hey, find the f of x area, subtract off the g of x area, and that gives me the part that's between the two curves. And so we have a formula set up here where the area is the integral from a to b. Basically, a is the lower bound, so there's my a. Here's my b value. Sometimes they work out to be nice x values. Sometimes we got to use the calculate tool on the calculator when they're ugly equations that we're working with. And we're going to practice some of those. But the formula is the areas from a to b of basically f of x minus g of x. It's the top equation minus the bottom. So it's the top minus the bottom. Whichever equation is on the top, it's subtracted by the equation on the bottom. The challenge is sometimes, depending on the equations they give us, they may overlap multiple times. And so anytime we change which equations on top and bottom, then we have to change kind of how we do things. We set up multiple integrals, and we get an example of that a little bit later. So I put a little note here. This is where f of x greater than g of x for all x and the closed interval from a to b. I put a note here is once the functions cross a different integral needs to be set up. Just thinking off the top of my head, if we draw it, what do I mean by that last statement? Let's think about the sine x graph and the cosine x graph. Okay? If I let f of x equals cosine x and g of x is equal to sine x, so we know cosine starts up at 1, it comes down, goes down, comes back up. Sorry, I missed the amount there. And then if I did sine x, we start at the origin, we come up, and then we go down and so forth. So an example of when I would set up different integrals would be the case if I asked to find what is the area between these two functions. Well, that's technically like this area, that area, and here the cosine's on top, then the sine's on top, then the cosine's on top. So you'd have to set up, and I'd have to tell you for like maybe from like 0 to 2 pi, is give you a closed interval from 0 to 2 pi. And so we would have to set up a different integral for each of those parts when they trade places, and we would have to find the transition parts. We would have to find out, okay, from 0 to this point, that's my first integral. And then, so let's call that A. And then I would add, whatever from A to the next point that they cross at. That's my B. And then I would add another integral. And then, I didn't sketch it perfectly, but then eventually I'd end up, B to maybe 2 pi. And so in this case, I'd have like 3 different integrals that I'd have to set up. So that's what that one statement is kind of saying is, if on a closed interval they intersect multiple times, then we need to set up a separate integral for each part. Okay. So problem number 1 is an example. Let's say find the area bounded by the curves y is equal to x squared plus 1. Well, again, if you didn't know, that's this one up here. Or sorry, x squared plus 2. And then the other one, that's my y equals negative x. That's that diagonal line, in case you didn't know. They told us that we're bounded from 0 to 1. So from x is equal to 0 to x is equal to 1. And so they are asking me to find what is that area there. Now, the nice part is we could get a good approximation because some of those are geometric. All right, I see 2 whole squares. I see a half of a square, a triangle. So I know the area's got to be more than 2.5. Okay, we got an area of 1 here, another one of 1. That's a half, and I know this is somewhere around a half-ish, approximately. I just don't know exactly. So if I was guessing on a multiple choice and I forgot stuff, I can at least narrow down some choices. I know it's going to be something bigger than 2.5. Probably around 3 something is what I'm thinking, because even that part up here in this little section here, that's somewhere close to a half is what that one is there. So I'm thinking it's close to 3. So using our formula up above here, I get to go to the integral from 0 to 1 because they tell me from 0 to 1. And then it's the F equation, which is the equations on top. The equation on top is the x squared plus 2. So x squared plus 2. That equation minus the bottom equation, which is the linear function. And then dx. And then, again, we can do this one by hand. So I'm going to clean this up. The integral from 0 to 1 of x squared plus x plus 2 dx. There's my cleaned up version. Distribute the negative and the minus. Rearrange it. And then now we would have x to the third over 3 plus x squared over 2 plus 2x evaluated from 0 to 1. And then we would go through and say, okay, it's 1 cubed over 3 plus 1 squared over 2 plus 2 times 1 minus, and technically it's 0 because everything else goes in there 0, so we don't have to do the second one all the way through. So I just got to figure out, okay, what is 1/3 plus 1/2 plus 2? So that would be 2 5/6, which is just a little less than 3. So it was right around that 3 mark that I was talking about. That would be 17/6 if we were doing improper fractions. So there is my exact area. Yes, you could use Math 9, but on that typical of a problem, they're not going to have you beat on a calculator portion. It's going to be showing your work like that on a free response. Okay? So the more we practice that, the better. Save the calculator one for the nasty ones and so forth. That way we don't get lazy in our skills. Number 2, they didn't give us a picture. And so they say find the area bounded by 2 minus x squared and the line y equals x. Now, even though they didn't give us a picture, we could still draw one. It's just you got to make sure you can draw an accurate representation without using the calculator. Okay? To me, you all should know y equals to x is the diagonal line there. Okay? So there's y is equal to x. I always associate it when it's a number minus x squared as a semicircle. Okay, that's what this one is. This is my semicircle. And so with that in mind, there's 1, there's 2. And so if I was drawing a semicircle, I know 1, 2. I know that's where I'm crossing there, and I have x-intercepts of 1.4, positive, negative 1.4. The area bounded by 2 minus x squared. Well, you know what? That means I get to go down this a little bit further. They didn't tell me an x, like 2x values, so this one I got to solve for the x values. So they don't tell me a left and right bound here. I have to figure out what is my a value here of where they're touching and what's my b value. I got to find those out. So, systems of equations. When does x equal 2 minus x squared? So when does x squared plus x minus 2 equals 0? That would be x plus 2 times x minus 1. So when x is equal to negative 2 and x is equal to positive 1. So negative 2 is my a. So that's negative 2 comma something. Don't care about the comma something. And that's 1 comma something. Oops, sorry. 1 comma something. So now I know what my a and b are. My a is negative 2. My b is positive 1. So as I now I can see the picture, which one's on top. So the integral from negative 2 to 1 of 2 minus x squared minus x dx. Negative 2, 1 of 2 minus x squared dx. So there's my cleaned up version. And then now we just got to go through it. So that's equal to 2x minus x squared over 2 minus x cubed over 3 evaluated from negative 2 to 1. Now this one I got to do both parts. Okay, I got fortunate on the other one with it being 0, so I didn't have to worry about subtracting. So this one I would want to make sure, again, can I do it by hand? Can we go through and say, all right, what is 2 times 1 minus 1 squared over 2 minus 1 cubed over 3 minus, now put the negative 2 in there, 2 times negative 2 minus negative 2 squared over 2, and then minus negative 2 cubed over 3. So that would be 2 minus a half minus a third, which would be, what is that? That'd be 5/6, so that'd be 1 1/6. So that'd be 7/6 minus, that's a negative 4. This would be negative 4 halves. That would be a positive 8/3. Let's make them all 6s. So negative 24/6 minus 12/6 plus 16/6, 7/6 minus, that's a negative 36. That'd be a negative 26. So that's equal to 37. Or sorry, man, that was bad, Mr. Stevens. 27/6. So 27/6 is my area. Anybody else get that? Make sure I didn't. So you know how I get, sometimes I get going too fast, I make a goofy mistake. Anybody else get that by yourselves? Anybody do math 9? You got that? Okay, so. Now, how do we know which equation is on top if we don't graph it? Yeah, guess and check. We know we still have to do this other part. We still have to do this part of solving for where they intersect. So now what you do is just pick a number in between my lower and upper bound and check it. Whoever has the greater answer means you're on top. So a great one here is to say, all right, let me use 0. 0 is in between negative 2 and 1. So, nearly. So 2 minus 0 equals 2. This would be y equals 0. Hey, 2 is bigger than 0, so that means it's the top equation. So you can always just pick a number that's between your lower and upper bound, plug it in, find the y answer, and say, okay, who's bigger? That's the thing that's got to be on top for the first equation before the minus sign. Now, here's where we got to be extra careful. When we think about top minus the bottom, top equation minus the bottom equation. On this first part of this graph here, the x-axis is the bottom equation. And then at 6, we change who is on the bottom. So that means that we have two integrals here. Where that change takes place tells me that I got to set up an integral for the left side and an integral for the right side. Even though they didn't cross, I changed who was on bottom. I went from the x-axis to then a diagonal line being on the bottom. So I have to have two integrals here, or two parts, okay? Because I want to find the area of the left part, add to it the area of the right part, okay? So starting on the left, we know we're going from 0 to 6. The square root graph is on top, so square root of x minus 0. I put minus 0 there because that's the x-axis. Now, do you have to do that? No. However, if we shift this graph some form or fashion and a y equals a number is the line that we're finding the error between, we got to use that number, okay? So I wanted to get in the habit of showing, hey, we would technically do the bottom function, which is 0, okay? So it's that dx plus the integral from 6 to, it looks like 9, of, again, the square root function minus, and then it's x minus 6 in parentheses dx. And then all they told us was to set it up, so I just want to clean that up. The integral from 0 to 6 of the square root of x dx plus the integral of 6 to 9 of square root of x minus x plus 6 dx. They did not ask me to find the area. We can. You can type that in into the calculator for Math 9, and you can do both of them. You know, you can do the first one plus the second one in the calculator if you want to. Questions so far? Again, little side note on that one. If the bottom boundary changes functions, a new integral needs to be made. So, bless you. On number 4, and again, little heads up here. Be careful of a rounding error. Little heads up. They want us to find the area between the curve y equals the ln of x and y equals 1/2 x minus 2. So, sketching the curve real quickly. Ln of x. We know it goes through 1, 0. Hugs the y-axis, comes up, intersects at 1, 0, and and then it's a slow rise from there. So there's the ln of x graph. Okay. Y equals 1/2 x minus 2. There's y is equal to 1/2 x minus 2. Our challenge here is that these two parts that they intersect, they're not pretty decimals. Okay, they're not pretty numbers. Because if you think about it, if I try to set ln of x equal to 1/2 x minus 2, in order to get rid of the ln, we have to do an e. So then it becomes x equals e to the 1/2 x minus 2. And I can't, there's no way to combine both x's. All right, so this is where we're going to use the calculator. So this is where we get to pull in. So this type of problem will only be on a calculator part of a test. And so I'm going to go in. And I got, oh, you know what? Let me reset it. Second plus 712. And then now y equals, I'm going to put the ln of x for y1, and for y2, I'm going to go 0.5x minus 2 just to speed up the process. I hit graph. I can see where they touch. Okay. Now I want to find those intersection parts, so let's use the calculator. Now I'm going to find the one on the left. Second trace, option 5. First curve. Where is my? Oh, there we go. All right, so I'm there. There we go. I tried to find my x's there. There we go. So with those two, tell me to guess it. So that one tells me on the left-hand side, this is 0.14555517. Now, remember, the more decimals, the better. Calculator is limited on how many it can show right there. But what we can do is we can use that storing option for us to store that value in there for a letter. So if you hopefully this works this time. If I press second, immediately go second quit, hit store, and then go alpha, and then A is math, alpha A, and hit enter. It's going to take that whole long X value and store it in for the letter A for me. So that when I do my Math 9 feature, I can just use A and B as my stuff. So for note-taking purposes, I'm going to say X is equal to that, and I'm going to store it into A. Okay, I'm going to store it in for A. And this is what we can do on a free response, is we say X is equal to that number, and then store it in for A, so that when I write my notation, I don't have to write the decimals. I can just use A and B's. Okay, now we're going to find the other intersection point. So I'm going to do second calculate, intersect. I'm going to go over to where the other one looks like it's happening. And I press enter. And sure, I press enter on that one. And you bet you guess it. And it tells me this one, that X is equal to 8.2109332. And I'm going to store it in for B. So again, I press second quit. Hit the store button above on. And then alpha apps gives me B. And I hit enter, and it takes that whole long decimal. Because remember, look how it took extra ones. It took 2 more place values, and it unrounded to 2. Okay, so it's giving me the more accurate I can be, the better. And so now they say find the area. So I'm going to find the area from A to B of the ln of x minus 1/2 x minus 2 dx. And then I'm going to simplify that and then put that into my equation. the integral from a to b of ln of x minus 0.5x plus 2. That's what I'm going to type in. So math 9, I'm going to go from alpha a up to alpha b, and then type in ln of x, close the parenthesis, minus 0.5x plus. Yeah, I should have done that. I should have done that. Would have been a heck of a lot easier. Thank you, Riley. You're exactly right. That saves a lot of the issues of distributing and all that other stuff. We could have done from a to b of y1 minus y2. You just want to make sure that if you're going to use that notation, make sure you say like y1 equals ln of x, y2 equals the 1/2 x minus 2. Make sure you define it for the reader. And then, yeah, that would be a heck of a lot easier way, especially in the calculator, since we did that. And then we go over there, press X, and then hit Enter. And that tells me that the area is 8.784. And there we go. That's rounded to the nearest third decimal.
Can you show us how you stored it again?
Sure, dear. So, again, as soon as I found so I think it can do it. So if I go, let me get that up on the screen. That way it knows what I want it to do. Because if I hit store right now, it's going to take 8.78. So if I go second, calculate, intersect, and I'm going to do that point right there because it's closest to it. So I'm going to press enter, and yes. So I got my intersection point. It's only going to take the X value when I do the store. So I'm going to press second mode to quit the screen. Because if you go immediately to store, it's going to give you an error. So you got to quit the screen. And then your immediately next thing to do is to press the STO button above on. Right above the on button, there's a STO. And then you go alpha, and then what letter do you want to put it in for? I'm going to use math because that's alpha A. And then I press enter. Now that decimal is put in there for that part. Okay? I know I had it in for B, but that's how you do it. Okay? But you have to press second quit to get off the graphing screen. Okay? And then immediately do it. If you wait too long and do another calculation, it's going to take the last calculation and put it in there. So you got to do it right out of that, coming off that screen. And again, that just speeds it up. You don't have to type in a lot of decimals and so forth. So the last one. Is it the last one? Yeah, it's the last one. Oh, yeah. So let R be bounded, the region bounded by the graphs. Y is equal to 2 square root of x, and y is equal to x squared over 4. So if you didn't know which one was which, this is y is equal to 2 square root of x. And this other one here is y equals x squared over 4. That's that one. Again, it's part of a parabola. We can see that they're crossing at the origin is where they're crossing at. So they're touching at 0, 0. They're crossing at here at 4, 4. Now, in case if they weren't and you had to find your A and B, you could go through and solve it. You could go through and say, okay, 2 square root of x equal to x squared over 4. When do they equal each other? I would multiply by 2, get the square root of x equals x squared over 2. Actually, I'd divide by 2, so that'd be over 8, sorry. Then I would square both sides and get x is equal to x to the 4th over 64. And then I would bring the x over and say 0 is equal to x to the 4th over 64 minus, boom, boom, boom. Technically, it's 64 over 64x. So then it becomes x to the 4 minus 64 x over 64. That's equal to 0. And then you would multiply by 64 to clear it. And then you get 0 is equal to x to the 4th minus 64x. Factor out an x. And then use the ZPP and say x is equal to 0. X cubed minus, 64 equals 0. And so you could use the cube root on that side. and say the cube root of 64, which is 4. So you can bring back all that algebra 2 work and stuff if you had to. Okay. Granted, this one looked perfect. They gave it to us as a setup that it was going to be 2 nice points. But just in case, they're not all like that. So now they said, okay, if the line x equals k divides R into 2 regions of equal area, what is the value of k? So where do we think it is? Maybe something like there. It's not on the 2 line, okay? Just because this is a lot fatter, that's a lot skinnier, and it's longer. So maybe some, so we got some like trade-off going on there. So I'm thinking it's somewhere around that amount, somewhere between 1 and 2. Looks like the rough split up between the 2 areas to be equal. So that is our k, and our goal is to find out what k is. Again, we find k a lot of times in other different situations. So as we start on the left-hand side, the first part, we would say the integral from 0 to k. Oop, that's a 4. The 0 to k of, okay, what equation's on top? 2 root x minus x squared over 4 dx. And then I get to set that equal to the integral from k to 4. And did we change top and bottom? No, they still stay the same. So it's still the same thing. Sweet, that makes it a little bit easier. All right. And then now we would go through and we'd integrate. So that would be 2 times x to the 3 halves times 2 thirds minus x to the 3rd over 4 times 1 over 3, because you have to do 4 times 3 in the bottom. And that's being evaluated from 0 to k. Yes, you have to do problems like this. Equals, we get to use the same thing. So I'm going to simplify the right side, say it's 4 thirds x to the 3 halves minus k to the 3rd over 12 from k to 4. So I went ahead and just simplified that side. I didn't have to do it again because it's the same equation. Now we need to evaluate combined like terms to where then we can solve for k. Okay, so now we would go through, put the k in there. So we get 4 thirds k to the 3 halves minus k cubed over 12. That's technically minus putting a 0 in there, so we don't have to worry about that part. Equals, and then it would be 4 thirds times 4 to the 3 halves minus 4 cubed over 12. Now that is being subtracted by, put the k in there. So that would be subtracted by 4 thirds k to the 3 halves minus k to the 3rd over 12. Woo, doggy. So the left side stays the way it is. So it's 4 thirds k to the 3 halves minus k to the 3rd over 12 equals, let's do some simplifying. The square root of 4 is 2. 2 cubed is 8. 8 times 4 is 32. So 32 thirds. 4 cubed is 64. So 64 twelfths. We can reduce that if we want to. Would not be a bad idea to reduce that. 64 twelfths reduces down to what? We can divide by 4. So isn't that 16 over 3? All right, so that makes it easier to combine the middle thing. Now I have distribute the negative, so I have a minus 4 thirds k to the 3 halves plus k cubed over 12, because we would distribute that minus sign. And let's see, I'm going to try to go over here, way down over yonder. Way down over here. As I clean this up, I say 4/3 k to the 3/2 minus k cubed over 12. On the right side, I have 32 minus 16 is 16/3. And then I have a minus 4/3 k to the 3/2 plus k to the third, or k to the third over 12. I need to bring over the 4/3 to the left, and same with the k to the 12. One's being added, one's being subtracted. They both get to be combined. So we get to combine with the fractions there. So that becomes 8/3 k to the 3/2 minus 2k cubed over 12. That's equal to 16/3. And then now, the only thing I can do here is just simplify my fractions. Okay. So now we come into the part of, do I want to try to factor it? I would say no. Now we go y1, y2. Left side into y1, right side into y2. Because as we noticed from the picture, it was going to be a decimal anyway. I've now got it into a point to where I can go into y1 and y2, and I can say, all right, for y1, I'm going to type in clear alpha y equals 8/3 x raised to the alpha power and then f to 1, then that'd be 3/2. Get out of the exponent location, and then I say minus alpha y equals 1/6, and then it's x to the third. So there's the first equation. The other thing, I just get to put in 16 divided by 3. So now that I typed those both in there, I'm going to find out, well, where do those two things intersect? So I'm going to hit graph. All right, sweet. A little bit different picture than I was thinking of looking at, but maybe not. I don't know. Did I type anything? Well, yeah, no, it should be different because I didn't type the same equation. So I want to find out where they intersect. Now, I only have to worry about the left point, okay? Because, again, we know the answer's got to be smaller than 2. Based on our picture up here, we got to be within 4. We got to be somewhere here between 0 and 4. So I don't have to worry about the far right intersection point. I want to do the left intersection point. So second trace, intersect, get close to that point on the left, hit enter, hit enter, hit enter, and it tells me 1.764. So they're telling me that they intersect at x is approximately 1.764. That's where they intersect. So k is equal to, or approximately, 1.764. There's the k value. Okay. So, could you have just typed in from the No, yeah, I was just trying to think, can you type in any sooner? I guess you could. I guess you could on one of these lines, once you put in the 0 and the K and the K and the 4, you could have typed that in there, Y1 and Y2 and so forth, but that was just a lot of typing and stuff. So I tried to get to a point to where it was just, hey, one equation, one side was an equation, the other side was a number. is all I tried to do. But you could have typed it in sooner for Y1 and Y2 and find the intersection. I just chose to simplify it further.
So for, in terms of y, we would just do a vertical line, and we would use 0 and 4 again.
What do you mean vertical line? What
Or a horizontal line. Because this on both.
Are you really working ahead of me?
I'm just thinking out loud right here. Because like the
probably-
y's
probably what?
in 0 to 4, so it's the same as the x's, so it would also be the same number. It's like if you're doing if x equals y.
Oh, yeah.
And you do this to this.
Is that a
here,
kid or is that an adult?
That's an adult.
There's also 0 to 4.
And then you would use, yes,
Or something.
something in that area. Yes.
Okay.
Yes, you would. Yeah. Now, the difference will be if you're using y values, you'd have to write the equations in terms of x equals in the process. That's what we do.
Okay.
So, we're making sure it stays